In this video, we're talking about linear equations and how to graph linear equations. In this particular problem, we've been asked to graph the linear equation given by y equals 2x plus 1. So let's talk for a second about what a linear equation actually is. First of all, we know it's an equation when there's an equal sign involved, and in this particular problem, we do have an equal sign. We have y equals 2x plus 1. So we know this is an equation. We know it's a linear equation because linear means that both variables that are involved, y and x, are linear, meaning they're raised to the first power, or that the exponent is 1. So this is y to the 1, or y to the first power, and x to the 1, or x to the first power. And we just don't write that because it's redundant. X is the same thing as x to the first. So this is a linear equation because both of our variables are linear. The graph of a linear equation is always going to be a line. So whenever you hear linear, you can think line. So if we want to draw a picture of what this equation looks like, the picture is going to be a line. Now, this particular equation, y equals 2x plus 1, is already given to us in what we call slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope of the line, meaning the degree to which the line slants right or left, and b is the point where the line intersects the y-axis. So these are two really critical pieces of information. If we have nothing but the slope and the y-intercept, then we can use those two pieces of information to graph the line. More specifically, the slope of the line we can define here as m, and it's really just the change in y over the change in x. So you'll hear it referred to as rise over run. As I mentioned, our equation is already in slope-intercept form, and if we identify m and b, we can say that m, or the slope, is equal to 2, and that b, the y-intercept, is equal to 1, so b equals 1. So if we want to graph this, we can still just take the y-intercept, which we know b equals 1, 1 is the y-intercept, and we can come up to this point here, 1, along the y-axis. And now we look at the slope here, we know that the slope is 2. If the slope is not given to us in a fraction, we can turn it into a fraction. 2 is the same as 2 over 1. So now with it in the form 2 over 1, we know that the change in y is going to be 2, the change in x is going to be 1, which means that for every 2 units we go up along the y-axis, right, this is positive 2, so we're going to go in the positive direction of the y-axis 2 units to here. We're going to go in the positive direction along the x-axis 1 unit because the change in x is 1. So we're going to go up 2 for y and then over 1 for x and plot another point. We can do that again. We can go up 2 for y and over 1 for x and plot another point here. Keep in mind that positive 2 over positive 1 is also the same thing as negative 2 over negative 1, right? Because both of these reduce to 2. 2 divided by 1 is 2. Negative 2 over negative 1, the negative signs cancel and you still get 2. This is convenient because if we know that it's the same as negative 2 over negative 1, then we can say we go negative 2 in the y direction every time we go negative 1 in the x direction. So we go negative 2 in the y direction, 1, 2, down along the y-axis, and then negative 1 in the x direction toward this negative direction of the x-axis, down 2 and over 1 this way. So now we have all these points and you can really see that our line is starting to take shape. We can draw a line through all of these points, and this line is now a picture of y equals 2x plus 1. This should make sense to us because a positive slope m means that the equation slants to the right. So if this is a perfectly vertical line here, and it's not perfectly vertical, but we'll pretend that it is, anything that slants to the right, so whether it's very steep like this, or it's more shallow like this, but it slants to the right, like so, then these are going to be positive slopes. M is going to be positive. If our line slants to the left, whether it's very steep like this or more shallow this way, if it slants to the left, then these are going to be negative slopes. M is going to be negative. So since our line slants to the right, we would expect the slope, M, to be positive, and in fact it is positive. It's a positive 2. Now keep in mind that you can always check your work with the graph here when you're graphing the equation of a line by plugging in points to this equation and then double checking to make sure that they're along the line that you drew. So we have this equation y equals 2x plus 1. We can just make a chart here of points for x and y, and the easiest points to pick for x are always negative 1, 0, and positive 1, because those should be easy to plug into our equation. So we can plug in these points. If we plug in negative 1 here for x, we're going to get y equals 2 times negative 1 plus 1. That's going to give us y equals 2 times negative 1 is negative 2. Negative 2 plus 1 is a negative 1. So we get y equals negative 1. If we plug x equals 0 into our original equation, we're going to get y equals 2 times 0 plus 1. Y equals 2 times 0 is 0. 0 plus 1 is 1, so we get y equals 1. If we plug in our point x equals 1, we're going to get y equals 2 times 1 plus 1. Y equals 2 times 1 is 2. 2 plus 1 is 3, so we get y equals 3. Then we can just plot these points and connect the points to form the line. So the point -1, -1, we go to the left along the x-axis 1 unit, that's in the negative direction of the x-axis. Then we go down along the y-axis 1 unit, and we get to this point right here. 0, 1, we start at 0 for x, and we just go up to 1 for y, that's right there. And then 1, 3, we go out to 1 along the x-axis, and then up to 3 along the y-axis, and we get this point right here. So you can see that instead of identifying the y-intercept and the slope and using those two things to graph the equation of the line, we could have instead just found coordinate points for x and y and used those to graph the equation of the line. Either way, both methods will work. Those are two methods you can use for graphing a linear equation.